Okay, we have 22 people in the meeting, so I think we can start. And while going through the first part of the meeting, hopefully the rest of the participants are going to join as well. Good morning, everybody. Welcome to this workshop training on QGIS and some basics of GIS. As mentioned in our email and our concept notes, ESCAP in collaboration with UNDP is basically processing a 2 years joint work through the SDG fund, working on strengthening risk and resilience in Maldives. And this project has a lot of different aspects, including strengthening the data capacities of Maldives, including the technical expertise of all of our colleagues on the ground in the country. So through the past year, we've had a lot of work done in terms of basically data processing, land use map, and risk projections in Maldives. And in the next few months, we're going to have a set of capacity building workshops for technical experts as well as non-technical individuals to be able to first learn how to basically prepare the data, understand the aspect of risk projection and how the data can be created, how the risk projection can be created, and then moving forward, how tools that ESCAP has developed can be used for management of risk in the country. Now, just to start the meeting today, I'm going to ask Dr. Sanjay Srivastava, the Chief of Disaster Risk Reduction in ESCAP from Bangkok, to open the meeting with his remark. Dr. Sanjay, please.
Yeah, thank you, Laila. Good morning to all of you, dear colleagues, especially Umar. I'm happy to see you online and many of the known faces. It's truly a privilege. We have some great memory working with Maldives since many years, especially after the Indian Ocean tsunami in 2004. So this program, I feel, is very important at this point of time because Maldives has taken up many initiatives which in coming days will transform the way disaster risk managements are taking place by multiple agencies in Maldives. Because for any of the DRR related events today or in the future, the most fundamental need is the data, and data that too in the format and in the manner, particularly in the digital format, which could be interoperable, which could be integrated with any models, is the key. And this project, and particularly this training, is very important step in that direction. I also saw Maldives has taken up climate loss and damage database initiatives. So this project and a skill in QGIS will really make a lot of difference the way the disaster risk management are in Maldives and particularly integrated into the multiple sectors. So I'm very happy that our colleagues, particularly Laila and Pragya, will be with you. They have worked with you very closely to develop the database, particularly the climate risk, the exposure database, vulnerability database, using QGIS. It's a very easy to use. I think you will realize it's more like a pleasure. It is something like Word and PowerPoint, the way we do day in, day out. QGIS is not a quantum mechanics, not a rocket science. It's a very easily public domain data system, which is available for the general audience. It is just like Word and PowerPoint. So I will request you to understand, especially how this software is downloaded, how it is used to organize data sets, integrate data sets with the many existing data platforms, develop a decision support system. So there are many steps, the variety of applications in Maldives context. Having worked with you, I think Pragya has developed. So I wish all the best for this training program. And from ESCAP side, with our partnership with Maldives Meteorological Service, with NDMA, we will be taking many of the activities in coming days together. So QGIS provides you a great opportunity to build the capacity of key stakeholder in Maldives, not only in DRR, but in multiple sectors, because all the new paradigms of managing natural resource, disaster risk management, and many other development sectors are going to be data intensive. And this is one way to integrate data coming from the multiple platform and build a decision support tool. So thank you very much for this opportunity. And we look forward that Maldives in coming days will become the really data users with QGIS, and I'm pretty sure this will be very helpful in managing your work. So thank you very much. Once again, my best wishes for this training program. Over to you, Laila.
Thank you, Sanjay ji. As you mentioned, I want to thank NDMA, MMS, LGA, all of the stakeholders. There are just so many that have been supporting the project, have been involved in the process so far. And we are hoping that as we finish with the work, they're going to continue and just keep improving with every aspect of the work, because at the end of the day, as you mentioned, it's all about Maldives and making sure that Maldives has that strong capacity and infrastructure in terms of risk and resilient management. Before we start with the next part, I just want to give a chance to kind of see what's the composition of the participants today. So I think since we have already 37 people in the meeting, it's going to be a little bit hard to have everybody one-on-one, you know, mentioning their name and organization. So let me start a poll, which I think everybody should be able to see. So you can open the poll, I think, and add the name of your organization. Feel free to add your name as well, because originally I was hoping to have a little bit of a more close kind of interaction, but I think it's a little bit too many individuals, and then we can share the results of the workshop. Okay, as everybody puts their information in the chat box, let me go over a few rules for the meeting today. During the meeting, it's going to be an interactive work. When one of our colleagues is presenting their part, still there are going to be other colleagues on the background to basically support and answer to questions. So if you have any questions as we go forward, feel free to put it in the chat box. And at the same time, during the meeting, at some points, we're going to have a special Q&A point when we are going to allow for people to actually unmute themselves if they want to ask question and basically discuss the issues that they have. we are going to start. So I already sent an email that was providing a very simple installation guideline, as well as a set of data sets that we're going to be using today for some of the sessions for practice, just to allow you a little bit more hands-on opportunity to work with the QGIS software. If you have not received the email due to late registration, or for whatever reason you didn't have a chance to download the data, my colleague Opera has shared the link on the chat box. Let me put it one more time just to make sure. So you can just click on the link and then download the installation guidelines as well as the data set. So we're going to start the meeting with one very small session going over the guideline installation, just to make sure nobody has any issues. And if there are any issues, you can directly message basically Opera in the private chat as we go ahead. And after that, we're going to hand the floor to Pragya Gupta, our specialist, to have a discussion about GIS for the first session. Okay, I think we've had a good enough time for the poll, so let's see if we can see the result. Rakesh, what is the method of seeing the result of the poll? Okay, while I'm figuring out how to...
Do you see that, Leila? It is 100% answered.
Yeah, but we don't see the answers. Can we see the answer?
Oh,
like,
okay.
Yeah, it shows the percentage of people in different options.
Okay, so while we are figuring out the poll, you can use the chat to just put your name and your organization as well, just as a kind of a startup introduction. And one very important thing, at the end of the meeting, we are going to share an evaluation form. And there's one specific question that asks if you are interested in follow-up training that are especially designed for Maldives, using Maldives data sets in terms of technical capacity of data analysis, data development and such. So please answer that question if you want us to directly follow up with you for the future workshop, aside from the follow-up that you're going to have with the organization and always. I'll stop here as people go ahead with the introduction. If, of course, you're interested to put your name and organization in the chat box, and give the floor to Opera Jain, one of our colleagues from the ESCAP office. Opera?
Yes, thank you, Leila. Can you hear me?
Yes.
Okay, so hello, everybody. My name is Opera. I'm an intern with the UNESCAP SSW office in New Delhi. And I'll quickly just share how to download this software in case anybody has any problem. So I'm sending the link to download in the chat. If you haven't downloaded it already, please visit this website. And let me share my screen. Okay. So if you click the link in the chat, you will visit this website. And it's pretty straightforward to download this QGIS, which is free open source software. First, please just choose the laptop or computer that you're using, Windows, Apple, Mac OS, Linux, whatever. So I'm using Windows, so I'm going to choose Windows. And there are two options. The latest one, download QGIS 3.30, or the most stable one, 3.28. So you can download either. Because, okay, when you click this, we don't need to donate right now. So when you click download QGIS, you will see the setup here, but it's more than 1 GB. So it might take some time depending on how strong your internet is. So I had downloaded the setup already. So when it's completed, you will see something like this in your browser. So just click on that. It's going to take a while to download or sorry, to open, or you can also just visit the folder and go to downloads. And this is the software, so double click on that. Don't worry if it's a little slow because it's a heavy software. Well, while it's opening, I'll just tell you the rule of thumb. So whenever you download any software from the internet, you will see something like this. And the rule of thumb is you just click yes, I agree, or next, whenever you see those options. So right now it's preparing to install. You just have to wait till it shows the option to press next. Do not click cancel. Okay, so now we can press next and I accept, next. So here, do not change any of the options, just leave everything as it is and keep clicking next. And finally install. So again, this might take a few minutes to complete.
Since it's going to take a few minutes
Yeah.
installation, what's going to be the next step after this?
So after this, can you see it? Okay, so maybe Zoom didn't show it, but there was a pop-up on my laptop which said, do you agree to make changes to your device? So when that pops up, just click yes. And then it's starting again. So again, it might take a few minutes. So just click next, next, next. And at the end, you will see finish button and just click finish and you're done.
Okay, thank you so much, Apra. Is there any other point that we have to be concerned about?
No, the rule of thumb, as I said before, is just to click yes, next, I agree, anytime you see those options. And this goes for any software that you download from the internet. But if anybody has any problem, please feel free to send me a message via chats. There is an option to send me a message privately. So just select my name and I will be glad to help you out.
Thank you so much, Apra. So one of the benefits of QGIS compared to other software is the fact that it's an open source software. Being a free option, I think it provides a lot more capacities for individuals to be able to actually use it and produce a lot of helpful documents out of that. I see we have our colleagues from UNDP as well, and the RC office, which I think unfortunately he has left right now. One thing that I want to do before we move on to Pragya's session, if those that are interested can turn on their camera, we can take a group photo just to remember this day. Okay, I think we have a few colleagues that have their background down, and it shows a beautiful but non-person view, Josephiah. Okay, perfect. So I'll take the picture. 3, 2, 1. One more, since we have a few more people added. And our interns, I recommend trying to help out as well with the process. 3, 2, 1. Perfect. Thank you, everybody. I'll give the floor to Pragya to start with a basic introduction into GIS. And as we mentioned, if you have an issue with the installation of the software while we are going through this session, please feel free to message Opera privately.
Thank you, Laila. Can everybody hear me?
Yes.
Okay, so my name is Pragya. Many of you have already met. We have met already during our stakeholder consultation, also during our midterm review we have done recently. So I know from the poll we have just done that many of the participant has good knowledge of GIS, but many doesn't have. So I would just share my screen and start a basic to introduce geographical information system and the basic concept of GIS, how the data is used, what are the different types of data we need, how do we do the analysis, all these things, to bring everybody up to the same level, so that when we go to the next session, we all know what to how to work on the data as well. So let me share my screen. Is it visible?
Yes.
I think. So good morning, everyone. Sorry, it took some time. So we are going to talk about introduction to geographic information system, and also in the later sessions, in next 2 sessions, we will introduce ourselves with with the QGIS software, how to work with the QGIS software using geospatial database. So just to revise, what is GIS? Basically, it is a system, primarily computer-based system, which is designed to capture, store, manipulate, analyze, manage, and present spatial or geographic data. It examines the spatial relationship. Spatial relationships means the objects that are placed over the Earth's surface and their patterns, and then trends in geography, and then it produces a kind of visualization of this geospatial information, which are manipulated and analyzed, in form of the maps. So if we see this, refer to this map here, it is a map of Adu et al. So what does GIS tells about this map? Where is something? Like when you see a map, it tells about that this map is of Adu et al, which is located at the southernmost part of Maldives. Why is something at the certain place? Because it is, if you look into the different colors here, they represent different land use categories. For example, agricultural areas, urban areas, reefs, and then lagoons, roads, vegetations, and water bodies. And where are they located? This also shows us, this maps also shows us. And what is in relation to something else? So we get to know that where exactly is the location of the specific land use category in terms of other objects which are already there in the map. For example, this lagoon is placed just on the east of this city, or this airport is located at the southern part of this whole atoll. We can find also some spatial pattern. For example, some of the eastern part of this atoll, and then northern western part of this atoll are heavily populated. There are some urban areas and agricultural areas. However, if you go to the southern parts, there are not much of populated areas are there. Also, which processes are working? This is a land use map, and we created some data, and we analyzed some data on the land use, and then we created this map, so we know which processes are working. And then what happens if, so when we want to understand what happens if we want to build kind of a new infrastructure here, then what will happen to the other associated objects which are already there. So GIS has the capability of telling us the answer of all these questions. So why do we need GIS? Can't we do these things with any other available information? For example, we have tabular Excel data like Excel sheets. We have kind of write-ups in Word. Why GIS? Do we need GIS to actually understand all this information or to see all this information? Because it simplifies the geographical analysis and presentation. Geographical analysis means anything which is located on the Earth's surface and has a locational features associated with it. It is very easy to update and edit the information that we create in the GIS environment. We can create new information by combining the existing data sets. It is very fast, and we can do a lot of simulations which are not possible manually. And it is more effective to actually send across the message because its visualization is very powerful. We can also integrate different disciplines, and when they are integrated, different authorities are also facilitated. For example, we can integrate different sectors with different information. For example, we can integrate economic information with the agricultural sector, and then we can visualize it in a map so that we have an understanding of what is the relation between these two sectors and disciplines. But we need to be very careful because it is a dumb system. How we guide it, manage analyze the data accordingly. If we guide it with wrong data or with the data which are not clean, then it will not create a good or useful information. So while selecting data or while working with the data, we need to be careful about cleaning the data and also selecting a particular data so that our information we get is meaningful and useful. So basically, there are 5 components of GIS. We are one of them. We are the users, we are the administrators, we are also application experts and also consumers. But we need a computer hardware like a computer, a network device, other devices like, you know, hardware devices like printers or plotters or digitizer to print maps. We definitely need a computer, and then the software. So there are ample of GIS software to create geographic data. One of the software which we will be learning today, which is QGIS. It is open source software. However, there are many software which are not open source, and they are also very powerful. We also need operating system and network software for our computers. The next important part is data, because we work with data in GIS. So we need data. There are different types of data we need. I will come into that different types of the types of data later on in my presentation. We also need to understand the methods. So when we analyze the data and we try to find patterns, then we need some standard operating procedures or guidelines or specification standards to follow and then produce the result we intend to produce. So when we talk about geospatial data, first, I would like to say that geographic data, we all know that it is represented in a map. What is a map? It is a plain model of a reality. So what we see on the Earth's surface, we see on a curved surface, but when we transfer it into GIS environment, we see as a plain model of the Earth's surface, and it's and the objects and everything it's there on the Earth's surface. So the reality is very, very complex. So we need to sort out relevant data, divide this data into different thematic groups, simplify different features to discrete object with same spatial references. For example, we need, if we are mapping one area, we need the information of that specific area. We cannot input data from Maldives and associate with the data from some other country, or for example, if we want to integrate data from a specific atoll, we need other data from that specific atoll. So spatial reference is very important while working with GIS, and also thematic group. For example, when we are working with agricultural sector, then we need data from the agricultural sector, but also we can integrate other sector which has a interconnection with agricultural sector as well. So geographical data can be different types. For example, cartographic data, those are maps. Topo sheets, if anybody knows, those are hand-drawn maps that used to be that we used to use earlier. Those are called cartographic data. We also have photographic data we see in the Google Earth or Google Map. Nowadays we use these things. We also have digital data, which is acquired by satellite sensors, and they are represented in a little different format than what we see on the Earth's surface. They also represent a specific area of the Earth's surface, but they are represented through digital numbers, and each digital number the data is collected through spectral signature and then represented through digital numbers. But we are not going into details of this data because we will not be using it in this project. Also, we have spreadsheet data that we can use it and import it into the GIS environment. So for geospatial data, we have two specific need and for the data types. One is spatial data, which is which has a geographical link and which is located on the Earth's surface. They are connected to a known place on the Earth and has a positional value expressed through latitude or longitude. So any point on Earth has their latitude and longitude. If it is a point, if it is a kind of a line, or if it is a area, then also it has a extent of that area. So we know from which latitude, longitude to which extent they are located. So that is the spatial data we need for GIS. Also, to relate to the spatial data, we need attribute data. So any other information apart from the location, which is associated with that specific object or specific location or specific spread of area, is called the attribute data. For example, here, the spatial data, I have shown it here in the picture. It is a atoll boundary of Maldives. So atoll boundary of Maldives is a spatial data because it is the location of the atolls on the earth. And then we have attribute data, which is the information of specific atolls, like the admin code or admin number. You can add numerous number of columns to add more information about the specific geographical features into the attribute table. And this information can be used for further analysis. So for spatial data, in GIS, we use two specific type of spatial data. One is vector data and another is raster data. In vector data, they are actually comprised of vertices and paths, and they represent through these basic symbols like point, line, or area that I was talking about. So when it is a kind of point feature, then it is represented as point. For example, if we have a mobile tower, it will be represented as a point. For example, we have location of petrol pumps. For example, we have location of critical infrastructure. They are point features. And we also have line features. For example, lines, they are represented as line feature. For example, rivers, streams, any network, any electrical network, they are represented as lines. And another feature is area, which are like if you want to have if you want to map and the spread of some specific features. For example, urban area where where it is clubbed into one place. So we can designate that area and draw an area and assign it as an area feature. But when we go to the raster data, it is represented through arrays, rows and columns. The number of rows and columns depends on the extent of the data, also the resolution of the data. So they are made up of pixel. Pixel, I think everybody knows because of the mobile phones. The pixel is the area in the raster data. The minimum area, which is with minimum area on the ground, which is represented in the raster data. For example, if we say that the raster data resolution is 1 kilometer, so the data, 1 pixel in the raster data represent 1 kilometer by 1 kilometer grid cell on ground. So that is the resolution. So if we have a higher resolution, we don't really say higher resolution. If we have a coarse resolution, that means the number of the area covered by 1 pixel is higher, then it is a coarse resolution. For example, 5 kilometer by 5 kilometer pixel is coarser than 1 kilometer by 1 kilometer pixel, because the 5 kilometer one, they represent a larger area. So the information into 1 pixel, they also get generalized. But if we zoom into, finer pixel value, then the object inside 1 pixel, they are more, clear. The information comes more clearly and more granularly, and we can use those data for granular analysis. This raster data are really regularly spaced. They are not discrete, but vector data are discrete. Each pixel in the raster data, they represent one value or one class. For example, if we have a raster data of, for example, precipitation, that precipitation data will be like, spread over some area, and each pixel will have the value of precipitation. It may be annual precipitation, it may be seasonal precipitation, daily precipitation, whatever unit it is or whatever temporal resolution it is. it will have a value for each and every pixel. Again, if we go for spatial raster spatial data, for example, land cover data sets, then the land cover data sets, they have specific values for each and every land cover classes. And then when they assign the values into different pixels, so they represent the aggregation of that of the number in a specific space. For example, if we have a river here, and if we assign 1 for river here, then when we have the data, we know that this is the land cover classes of river, and rest of the area we can assign any other number for any other class, and they can represent that class. So this can be done by numerous, a lot of different classes we can use, and then, according to our needs.
Can I ask a question before we move to the next part?
In
our project, we use a term downscale data a lot. So is it referring to this raster data?
Yes, the climate projection data we are using is in this project is a raster data, which is a continuous data of the precipitation value. And each cell has a value of the precipitation for 1 kilometer of 1 kilometer grid. 5 kilometer by 5 kilometer grid. The data we are using is 5 kilometer resolution.
One more question. So each one of these pixels, if they have, because they're covering, as you mentioned, a specific area based on the level of the details. So let's say in a 5 kilometer to 5 kilometer, if we have both river and urban area, what does it show? Does it respond to both of them, or the one that takes the majority of the space in the in that one pixel?
It represents one value.
Okay.
So it doesn't segregate the urban and agriculture if it is in the same pixel.
So a smaller pixel provides better detail.
Detailed information. Yeah.
Thank you.
Yep. So so this picture shows how changing the resolution can impact the quality of the data. So the first one is 8 meter, which is coarser resolution. And this coarse and fine resolution depends on the purpose of the use of the data. For example, if we are doing kind of a global analysis, then the data needs to be very coarse. Otherwise, it is difficult to analyze the data in a normal computer, or we will need a server or something. But if we are doing for a smaller area, then downscaled data represents better information. They convey better information. So for example, here, this 8 meter data looks to be much coarser. When we go from 8 meter to 1 meter, we can actually visually see different land use classes here. So that's how the resolution, changes the information extracted from the raster data. So extent in a raster data, they have two specific property: resolution I have already discussed, and then extent, that is the overall geographic coverage of the spatial data. For example, if we have a spatial data for the entire Maldives, so it will have a extent of Maldives. But if we have a spatial data for a particular atoll, then it will have that extent of the particular atoll. Extent is, of course, expressed in latitude and longitude in northeast, southwest. So there are different types of rasters. Discrete rasters have distinct themes or categories. For example, land use cover classes or soil types, which I was talking about, and then continuous raster, for example, elevation data or temperature or precipitation data that I mentioned. So if we want to compare the raster data and the vector data, they have different purpose and different uses. Raster data, if you see that, this is a categorized data. So this pixel have a specific value, for example, 1, and this pixel have 2, and this pixels have 3. This is an example of land cover classes. So they represent the continuous variation very well. They represent district variation a little poorly. They have a simple data structure, and they have relatively larger file size. But if we go to the vector data, they represent continuous a little poorly than raster data, but represent the discrete variation very well. They have very complex data structure because when we have a lot of vector data sets together, then we need to understand then we need to understand as well as tell the software to understand the relationship between different features on that vector data. So it is a bit complicated, and also we have the associated table attribute data. That's why this vector data a bit complex. It has relatively smaller file size, so it's easy to handle. Now I'll come to the coordinate reference system for a bit. And this is because we are dealing with locational data. We need the coordinate reference system to actually understand exactly where the is on the Earth surface. So the coordinate reference system, for it, the geographical location of any object on Earth, they can be represented considering different models of Earth. For example, we can assume the Earth is spherical, or we can assume the Earth is planar. So these referencing systems are called coordinate reference system. Primarily, there are two different reference systems. One is geographical coordinate systems, which considers Earth as a spherical model. This one. And there is another system which called projected coordinate system, where the Earth surface is converted to a planar surface, and the coordinate system is developed based on that planar surface. So what is the difference between these two coordinate systems? Both of them identify locations on the Earth, but one is on curved surface, one is on the flat surface, that is map. GIS measures the locations on Earth's surface in angular unit. So when we have the geographical coordinate system, when the data have geographical coordinate system, it shows the CRS in degrees, minutes, and seconds, or degree decimals. But when we go to the projected coordinate system, it shows the data in linear unit, for example, meters, centimeters, kilometers, miles, etc. In GIS, it defines location by latitudinal value and longitudinal value, but in projected coordinate system, they have an origin, an x-axis and y-axis, and a linear unit of measurement. One example which we generally use it for GIS is WGS 84. This is the most commonly used referencing system. And then for the projected coordinate system, we have a universal transverse marketed system, which is most widely used, and it is actually divided into different zones across the Earth. So when we assign the projected coordinate system as UTM, we also need to define the zone. And there is a standard map of how these UTM zones are located, where it is located. So it is pretty easy to find out. So what do we do with this data? So we do geospatial analysis, of course, to extract some meaningful information. Three most important analysis very commonly used in GIS is spatial analysis, network analysis, and 3D analysis. Spatial analysis is the one where spatial relations are explored. And for example, if we look into this map, this is a map of many of you have already seen this map during midterm review. So this map tells us about the total annual precipitation during different time period and different climate change scenarios. And then it is telling us how the precipitation values are changing across the country. For example, there is red area represent the areas where there are more precipitation. And if we go from red to blue, the precipitation amount changes. So we can associate this data, the spatial relationship between the atolls or between different locations of the country with the information of precipitation. So this is called spatial analysis. Then we have network analysis that looks into geographical networks. For example, we want to know the shortest distance. We always use Google Maps. Google Map uses network information to guide us through the roads, and they use the road network and the length of the road network to calculate internally the shortest distance between 2 points. And the 3D analysis looks the spatial relationship in 3 dimensions. For example, if we have an elevation model and like the topography of an area, which area is higher, highly elevated, which area has lower elevation. And then if we want to know which areas are going to be inundated during flood, like we see in this figure, in this picture, that some of the area are being inundated, but some are not, because these areas are a little higher in terms of elevation, while these are a little lower in terms of elevation. So the analysis looks into the variation of the dimension, not only the linear dimension in X and Y axis, but also in the Z axis, to understand which areas are going to be inundated and how high will be the level of water if it gets inundated by specific amount of precipitation or specific amount of intensity of storm or coastal sea swells. So these are some of the basic things I wanted to discuss before we go to the main hands-on session. So I'm happy to answer any questions if you have on the basic part of GIS. Thank you.
If anybody has any question, feel free to unmute yourself right now. I think we have a little bit of a time to have a discussion if there is any question regarding the information that was shared. So, Pragya, we have one question in the chat from Mr. Muhammad Imad from National Planning Institution. You're muted.
Yeah, please go ahead if you want to ask. I could see your question. I can answer, but if you want to add anything, I can also answer. Okay, let me answer this question. So 2 different CRS I have given the example of. So basically one is Geographic Reference System, that is GCS, Geographic Coordinate Systems, GCS. So that is actually when we map, we always use the GCS first to map the any feature on the Earth surface. But when we want to understand, for example, when we want to estimate any linear units, any linear dimension out of that map, for example, if we want to know the length of the road which might be inundated due to flood, we cannot do it using the geographic coordinate system because the unit is in angular, like it gives us the data in degree, minute, and seconds. But it needs to be transformed into a flat, planar reference system, so that we can calculate, the system can calculate the distance between two points in terms of linear units, for example, kilometers, meters, or miles, or any linear unit. So when we want to understand, when we want to calculate this kind of, we want this kind of information out of our map or out of our data, we need to transform it into, or for example, if we want to calculate area of a particular land use class, for example, agriculture, we have a cluster of agricultural area together, and we want to know how big is the agricultural area in a particular atoll or particular island. So then we cannot understand it using the geographic coordinate system because it is in degree, minutes, and seconds. We need to understand in square kilometer or square meter or square miles. So then we use the planar system, projected coordinate system. I don't know about Planet Lab specifically, but there are a lot of satellite. We can use QGIS because satellite imageries are raster data I was talking about. So QGIS is very capable of handling.
Read the question for everybody to be aware.
Okay, how can we link between QGIS with Planet, in bracket Planet Labs, for getting satellite imageries? So getting satellite imageries, I don't know about particularly Planet Labs. We will be showing how to import some of the satellite imageries into the QGIS environment and then work on that images. But if you want specifically Planet Labs, then or any other satellite imageries which are not already linked with QGIS, then you can anyway download from the source, and then we can always import the data into the QGIS environment. It's completely possible. I would like to ask about spatial analysis map shown in the presentation. It shows that central part of Maldives is more prone to flood compared to other areas. However, we observe many flood events in South Maldives too. Is it due to lack of data that map is not showing red color to south? Okay, the map I showed is the projection data, not what is happening right now. So
share the map, Prangya, just so that everybody knows which map you're talking about.
Yes, sure. Let me share my screen once again. Share. I think you're talking about this map. So this map is climate projection. So we have different scenarios here. Climate projection scenarios, which are standard scenarios developed by IPCC. According to the scenarios, there are some data available, climate projection data. So this climate projection data tells us that with the current rate of climate change or the greenhouse gas emission, or with the greenhouse gas emission which is little higher than that, what might be the pattern of precipitation in different areas on the earth. So according to those data, it shows that it might happen like this, that most of the central part might get more precipitation than the other parts. Also, if you look at the data a bit clearly, I'll just put it in a slide mode. So if you look at the data a bit more clearly, so these are the ranges of precipitation. Blue represents the minimum range and red represents the highest amount of precipitation. So if you are talking that your southern regions are getting more precipitation than earlier, yes, of course. If you see here, across different scenarios. The orange part, which is also, I mean, just the next highest range from red, are expanding down south in some of the scenarios. Now, I mean, it is very difficult to say now that which scenario the globe will follow, but generally this one, the second one, is the business as usual scenario. So if we don't do any adaptation activity, if we don't take care of the global emissions, then this scenario, this kind of spatial pattern of precipitation we might get for Maldives. And if we go to this kind of scenario, SSP3, which is like a bit more, challenging scenario where we are expecting more emission, more, impact of climate change, then maybe this kind of scenario, this might happen in the future. I think I lost the questions. Oh, I'll just stop share chat box. So can you give can you give some real-time examples where we use discrete vector spatial data? We will come to that section in in part, I mean, later on in the in session 3. So we will give some examples as well. I think that's it. We don't have any more questions.
Okay, one thing I want to add, the map that actually was just discussed is a part of the ongoing work that ESCAP is doing right now for the risk projection in Maldives. And in the next workshops that hopefully is going to be in person, hopefully in July, we are going to go over specific details of the data that is available, how these maps were created, and have a capacity building on that aspect. Okay, I think we can take around 10 minutes of break. Right now it's in Maldives time, I think 10:05, if I'm not mistaken. So 10:15, we can get back and start with the second part where our colleague, national consultant from Maldives, Mr. Ismail Biaz, is going to go over some of the basics, introductions to the QGIS software. So see you all in about 10 minutes. We are on the background, so if you have any questions for other people that didn't get a chance to ask their questions, feel free to add it to the chat box and we can individually answer. Thank you, everybody.
Yeah, another thing I just want to add that in next 2 sessions, we will be using data and the software to showcase the operations, the toolbars and the functionalities. So if you still have not downloaded the software, you can download in the break. And also if you have any difficulties, you can always reach out to us. And I think we have also extended some of the data along with our when you have registered in the for the webinar. So we will also need those data if you want to practice with us for the next 2 sessions. Thank you.
So we share the link once more for those people that didn't see it previously in the chat. You can get access to the installation guideline as well as the data set that we're going to be using for the rest of the day. Thank you. Okay, it's 10:15. Mali time. So we can start the second part of the session if everybody is here. So one thing I want to ask everyone, you can use the reaction box to answer how many of you have the QGIS software installed right now? Just knowing how many are going to have the hands-on experience. Okay, let's give it a minute. So if you have the QGIS installed, please raise your hand or clap or thumbs up, either one of the characters that shows you have it. Okay, so around 8-9 people. I hope it's more. But one thing that I want to mention. Oh, lovely. So I see in the chat box, they are people that have it installed. I hope you can go through the installation as we are going through the first part of the session today, just because, you know, being able to actually practice with the data provides a better opportunity for you to figure out what parts actually might be a little bit confusing when you are applying the things that you have learned to the practical aspect. On that front, we are going to provide a YouTube link to this specific workshop later on for those people who might want to kind of go back into the training either from the GIS part or the QGIS aspects of using the software. And we are in the process of preparing a manual for the information that is going to be shared today. So in the next week, hopefully, we are going to share the information of the manual as well to help you with a little bit more information as you're practicing the work of the workshop. And as I mentioned before, we are hoping to have our next capacity building, which is going to be in person in Maldives in July. So it would be really helpful if you can make sure to go over the fundamentals that we are covering today so that you are prepared for the next workshop to enter a more advanced kind of work, basically progress with the QGIS and the methodologies that this project is covering. Okay, I'm going to stop here and give the floor to Ismail, who is our colleague from Maldives. Ismail is going to start with an introduction to the QGIS software and some of the basics. Ismail, floor is on.
Thank you, Leila. Can everyone hear me?
Yes.
Okay. Thank you, everyone. It's so nice to see you all. My name is Ismail GIS, and I'm working as a national consultant for this project. I believe from the previous sessions, you have already understood how to download and install QGIS. My part may be a bit boring for those who are already familiar with QGIS, but this will be very helpful for anyone who's starting up with this program. So, as Leila mentioned, on my I will be mostly elaborating on the startup of the program and the main features, the main programs, how to navigate through those tools and all. So to begin with, I will share my screen. Is my screen visible now? Okay. So first thing I want to do is for
At least I cannot see the screen yet.
Okay,
What about the other colleagues?
can't. Okay. How it now?
Yes, we can see your desktop and the chat box.
Yeah. The first thing I want to do is, as for all other programs, I will just find where the program is and open. In this case, here is on my start menu. I will just open the QGIS. For those who have already downloaded and installed the program, it will be easier, like for you to follow me after my presentation. Maybe otherwise you won't see it. So now the program is open, and when you open QGIS, these are the options that you will be asked with. Okay. These are the options that you will be asked when you open the QGIS. One option is whether you want to start a new empty project, or there's also options for you to open most recent projects that you have worked with, or otherwise there's also options for you to load an existing project for you to continue with and save project. First, I will show you how to. I will open a new empty project. So for that, you just have to click on that. Now we have an empty project for us to start fresh. And before proceeding with adding layers and all, I also want to show you how we can load any existing project. We can continue an existing project. To do that, let me save this file so that we can continue with the same thing. To save any project in QGIS, you have to go to the top left corner, which is in project, and save as. And in this case, I have the folder for this UNESCAP training, and you find the correct location where you want to save the file, and just name the file. This time I will name this file as training. So this is just very similar patterns that we use for all the programs. So I'm sure that you will be familiar with. So I will save this project as training, and let me again close and open QGIS again. Okay, so now we have that same window as earlier. This time what I want to do is I want to open an existing project or continue with a saved file. To do that, also we have to go to the project, and you go to open. This is the similar for all other programs too. So now I have the file that I saved earlier. It's the training file. We can open this, and since I didn't do any I didn't add any layer or anything, it was left empty. Now what I will do is I will show you how to add any layer to a map. To add a layer, what you have to do is you go to the fourth tab on the menu bar, which is layer, and from layer you have to go to the add layer. When you open add layer, you will see multiple types of layers options that you want to add, and in this context we will mainly focus on vector layers and raster layers. I'm sure that you have got many information regarding vector and raster layers from the previous session. To proceed with, I will first add a raster layer. add a raster layer, from when you add a layer, you make sure from this left side that the correct format, the correct type of layer is selected here. In this case, what I want to do is select raster, and this is where you navigate through the folders to find the file that you want to open or you want to import to QGIS. So browse through the folders. This time, in this case, it's in the session 2 training folder. And when you want to add a layer like raster or vector to QGIS, it's very important you to confirm the type of the file. In case of a raster, it should be a TIFF file. Otherwise, if the format is wrong, you won't be able to import it correctly. So in this case, I have selected raster and I want to add a raster file. So I will select this TIFF file, and you click open. After that, this window will appear where you can confirm whether you have selected the correct file that you want to add, and if it's okay, you can proceed to add. So now that that file will be is added to the main window. So I will just close this to confirm. Now you see that raster layer has been added to the window, and in the panel in the panels you see that the raster layer is now added. Also, I want to show you how to add a vector layer. To add a vector layer too, you just have to repeat the process by going to the layer and go to the add layer, and this time you can select a vector layer. And as I said before, you while like you want to add any layer, this window will appear, and make sure on the left side that the correct type of layer is selected. Earlier it was raster. This time I want to add a vector layer, so this is a vector layer. It's correct. So I will just go to the folder. So in case of a vector layer, earlier for raster, it was a TIFF file. In case of a vector layer, you make sure that the file type that you are selecting to import is a shape file. Only a shape file can be imported as a vector to the QGIS. So this time I am trying to add atoll boundary of Maldives in 2016. It's this shape file. I will just select and repeat as early. So now you see that you confirm that the correct file is added, and if it's okay to proceed, you can just add the file. Now that vector file is also added to the main map window. Now you see the Maldivian boundary is added as a vector file. So from this point, I will just go through the main menus and interface of the QGIS.
Before going ahead, Ismail, can I ask a question? What would happen if we choose the wrong format of the file?
Okay, let me show you what will happen if a wrong file is added. If you want to add a layer, there is also a shortcut. You just go to this left column, this icon, the same window will appear. So rather than going to that layer and selecting vector or raster, you can just go to this this icon too. This time, which format was selected? Yeah, this time I want to add a vector, and I will just go to the folder, and other than selecting a shapefile, let us select this this file. So an error message will appear on top of the window saying that it's not a valid or recognized data source.
Thank you.
Let me go through the main features and main menus of QGIS. Yeah, on top of the window, this you will see the menu bar. So in the menu bar, we have the main functions such as project, edit, view, layer, settings, and all. I will go through one on one each. I think project, you already know the what we use for what's the use of this project function. For projects, we use to open, close, save, and import files. And edit function we use to edit the selected layer, or to edit the attribute table of a selected layer and all. More detailed functions of this edit will be explained in the next session, while processing with these with these vector layers and raster layers. And view tab, the use of view tab is to zoom in, zoom out, and set the screen to a certain scale and all. Layer, in layer, we have options to create layer, to add a layers, add a layer as I shown earlier, and also you can open attribute tables or edit the attribute tables and all.
So Ismail, if you go over the tabs a little bit slower,
Yeah.
So that everybody can follow. And please, again, if you have a question, raise your hand or put it in the chat box so that we can answer as we go ahead.
Yeah. Okay. I'm sorry if I was going a bit quick. So the next is plugins. In QGIS, we already have many default functions installed in this, but there are sometimes where we want to add a new function which is not already installed by default, and in that case. In that case, the function that we have to go is to these plugins, and you go to the plugins. Here is multiple of new functions that's not installed by default. That's not already in the QGIS. So to install any such plugins, what you can do is you just select the plugin that you want to add, and you can click on that, and once it will give you a brief detail about the plugin that you are about to install. And if you're good with that and you want to proceed, you just go and install the plugins.
Can we maybe try one plugin to see like what is the benefits of plugins, or what would it add? Is there any option that we can try one of them?
I think later in the next session, we can try to add a plugin and see those options. So the next function is vector. The use of this vector function is like when you have a vector layer added to the program, you want to process, you want to like crop, or you want to do any editing to the vector file, then within this menu bar you will find all these. If you want to make a buffer in the vector file that you have, if you want to clip, or all these functions you have under this vector menu. And likewise, for this raster also. If you have a raster layer already open in the map and you want to do some editing to the raster layer, you want to do analysis, you want to do projection, this is where you can find all these functions.
One step back, Ismail, the vector part, the clip and other stuff that you mentioned. Can you go to the vector?
Yeah, the vector.
So this geoprocessing tools that you mentioned. So what is buffer clip? What is the use of this specific tools?
Okay, so if you want to you have a location to develop a project, and in case if the proponent wants to know what would be the like 10 meter or 100 meter buffer zone, where which comes under this within the perimeter of this project zone. So in that case, you have to go to buffer, and you can make a buffer around that project or around that zone by using that buffer.
Great, thank you. And we have a question. Can you please repeat in which scenarios we need plugins?
Sorry.
Somebody has asked, can you please repeat in what scenarios we need plugins?
As I said early, in QGIS, we already have many default functions, and in case if we want to process a file where where that function is not already installed in QGIS, and we want to add by using import plugins, we have many other functions that we can add to the QGIS. In that case, or else you can just search the type of function that you want, which is already not installed in the program while you start with. And in that case, you just go to the plugin and you can install. So that function will be later available for you to do the processing and all.
Just to add, if you can see in the window, if you can expand the first bar, Ismail. So there are a list of options like installed, not installed, upgradable, installed from zip, and setting. So installed part will show you what are the processing toolbox which are already installed in your QGIS system, and not installed will show you what are not. So if you need any program which are not installed, for example, any annotation to label, for example, if you go to annotation to label, if you want to add this program, this function to your processing toolbox, you need to go to plugin and install that. When you install that, it will be available in your processing toolbox. I think processing toolbox, Ismail will explain a bit later. Then you can use the that tool. So in that case, you need to install a tool when it is not already installed.
Okay, great, thank you. Before we go further, let's just take a minute of break and see if there are questions so far that need to be answered. So we had one question from Iruzam Abdullah, MLSA. Was the issue resolved? The problem with not being...
No, they're still not able to add any layer.
Okay, so can you just maybe explain the steps that you go through? So you already opened a new page and then you went to the layer, add vector layer, and then the data.
Hi, Leila, were you talking to me?
No. It Miss Iruzam is having a problem with basically one of the steps that you explained. So I just want to make sure that before we go ahead, that very first stage problem is resolved.
Lelo?
Yes.
They're saying that when they import the file, they're getting an error saying no transform available between unnamed and custom CRS.
Okay.
is
Yeah, actually, no, you don't use that file. You have to use specifically the file that Ismail is telling, that is Maldives boundary. You cannot add other files. You just add the file that Ismail is telling, because other files are for specifically tailored for other operations. So when you go to the other file, for example, it is written clip no CRS. If you want to open it, then it will give you that warning. So please go to the other one, which doesn't have that no CRS in its name.
So, Ismail, can you point the right file that in this case has to be used for the first vector?
Like if you are about to add any vector file, you select the file, this atoll boundary 2016 shape file. And in case you're trying to add a raster file, maybe you are trying to add a raster file with this clip no CRS. We will later go to this CRS part, and what will happen if we try to add a layer with no CRS. I will explain it later. But for now, when we are adding, make sure that you add this raster file, this TIFF file. The name has no CRS on it.
Okay, so I hope other participants that are trying the ads don't have that issue. And if it still continues, you can message directly to Prangya. And we have a question that is asking if it's okay, the colors of atolls are different in their version.
The color, how to change the color and all is, I will explain during this upcoming parts, and it's not an issue if you have a different color while you import the vector file.
Okay, great. So it's based on the pre-default of the person's program, what color the layers are going to show. Is that correct?
It's flexible. It's really flexible. We can just make any we can go to the property and change the symbology of the layers anytime that we want it. So it's not an issue.
Thank you.
So to continue with, I think I was here in database. So the use of this database is like the database menu allows you to connect to the existing database, and I will not go very technical into this, because some of those will not make much sense. And next, I want to show you the processing toolbox. As Prangya was explaining, if you add any plugins to the to the window, it will appear on the processing toolbox. So the processing toolbox in this case, it's already selected for us to appear on the window. If I unclick it, though that menu is will go, and if I want to keep the toolbox on the window, you just click on this toolbox. And the use of toolbox is actually this toolbox. It's used to use as a shortcut to find any function that you want, rather than going to these menus and navigating through all those things. If you just want to edit or clip a vector file, you just you can just right click on this search bar, and all the options, all the functions available under clipping will appear on this processing toolbox. So it's quite easy if you want to save time and like go to the correct function by a shortcut. So that's all about the top menu bar, and down from the menu bar, what we see is the toolbox here. And for toolbox, if you want to add or remove anything from the toolbox, what you have to go and do is you go to the settings yeah, you have to go to the view, and from view you will see this toolbars, and these are the tools that is like available for you to import or for you to use on QGIS, and like if you want to add any tool to that toolbar, you just click check, and that tool will appear. Or if you want to remove any existing tool from that menu, you also can go and unclick it, and the tool will go. So the next is these panels. On the panel area, you will see all the layers which are already open on this map, and in this case it's the two layers, the vector layer and the raster layer. In the panel area, you can also like expand it and see what are the information within this layer, or you can like use this panel area to rearrange the files, whether you want to bring this layer down, or you want to bring this layer on top of this. All those you can do it, or if you want, you can even make a duplicate of the layer, or like for each of these layer, you will find like additional options by right clicking on it, and you can go to the property, you can open the attribute table, you can like edit the attribute table, or you can export it to a different format. You have a lot of functions in this panel area by going to that specific layer, and by right clicking. And the next area is the map view area. The map view area is like it will show you all the layers that has already been like added to this map, and if you want to unclick, if you want to hide this layer, you can just go and unclick that raster layer on the background will go, or you can just bring it back like this. And also you can zoom in, zoom out, and toggle through the window this map, and through this map view. And the next part on QGIS, it's the status bar. On the status bar, you will find on this down of this window, and on the status bar, what you see is you see the coordinate. If you move through the window, your mouse, the coordinate itself will keep changing. And also you have the scale, how much scale, how much magnification you want on your map. The scale will keep changing. Also you have CRS, which was very explained in detail on the previous session. The CRS, like coordinate reference system. As one of participant had some problem by trying to add a file with no CRS. Let me show you how what will happen if we try to add a file with no CRS. To add a file, we repeat the same process as early. We go to the add layer, and go to raster and select the file that we want to add, and we have the TIFF raster file with no CRS. We can try to add the file here. And if everything is correct, we can go to the add, and now the same error message will pop. In that case, no transform available between unnamed and EPST 4326 error. So what you can do is first let me show you information of the raster file where this CRS is already added. So this is the raster file which was previously To find whether your layer has the CRS or not, you can just go to the panel and find that layer and right click on it and select properties. So on properties, you will find a section called Coordinate Reference System, CRS. In this case, the first layer that we try to add, it has CRS already assigned onto that layer, and that's EPEST 4326 WGS 84. So in case on the next scenario where we have a file, we have a layer without CRS assigned, and also you want to add that add CRS to that file, what you can do is there are two options. One option is going to the setting, and you have to navigate through some menus. The easiest way would be you go to that layer, you just right click on it, and you can go to this layer CRS. On the layer CRS, in my case, since I have recently used this projection, this CRS, by default these things appear. But in your case, since if you are starting fresh, maybe these won't be on your computer. So you can go to set layer CRS. On set layer CRS, you go to this geographic coordinate system. On geographic coordinate system, see, the thing is, since I have recently used this reference systems on my window, this WGS 84 EPST 4326 is visible. This is the reference system that we want to assign, but in your case it may not be there. So what we have to do is we go to this geographic coordinate system. We want to find WGS 84. Yeah, so WGS 84, you just find name with only WGS 84 with nothing more in associate with that name. And when you select that reference system, you make sure that it has the correct EPST number, which is what we want to select is 4326. And after that, you can just go and click OK. So now to confirm whether we have the correct CRS EPST CRS assigned, we can go to this to that layer and right click on it, go to properties, on information, on coordinate reference system. Now we have that the correct CRS added to that file. So that's how you can assign a CRS to any layer which already there's no CRS assigned. And before I conclude with my presentation, I also want to add suppose you want to add an open source map like Google Map or Google Satellite or any map to this GIS. In case you want to georeference a map or do and take a snapshot of an area of a map or from the Google Earth or Google Map. In that case, what you can do is you have to go to the in this menu. There's already, in my case, Google Maps and Google Satellite is added. I will just remove these connections so that I can do that again. So on the this text, we will add the links and URLs of what I am about to copy for this process. You can just refer to those if you want to add any of that open source maps. You can go to this XYZ tiles on the left side of the window, and you can right click on it. From there you can go to a new connection, and this time I want to add Google Maps to this. So what you can do is you can name it so to add those we have number of URL links for each of these maps assigned. In this case, I want to add Google Maps. Then you can do is you can copy this link and you can just paste the link here and keep all other areas as it is as default. And you can just click OK on it. Now on that XYZ tiles below, when you expand the menu, you will see that Google Maps is added. And if you want to add this Google Map layer to the QGIS, what you can do is you can just double click on it. Based on your strength of internet connection, the Google Maps should appear soon. Let me just unpick this. Let me do that process again. There might be a problem. Let's try Google Satellite. Yeah. So now that Google Satellite Map is visible on my map view area, you can repeat the process for any of these open source map, whether it's Google Maps or Satellite or Google Satellite Hybrid or any of this. We will copy these links to the chat box for that, so that you can refer to those. So yeah, I think that's all for my part. If anyone has any questions regarding any of it, you can go ahead.
Opera, can you share the link for the Google Map, the ones that Ismail just went through in the chat box for everybody?
Yes, I'll send it again.
Thank you. Okay, let's start one by one. Maybe from the very start point, those that have problem with seeing the layers. So how many people have that issue right now? They couldn't manage to bring the layer into the file, into the project.
Can you repeat adding WGS 84 reference? Of course, yeah. To add the reference.
Let's go one by one, because we have some question from the previous parts as well. It would make it easier.
Yeah.
So we had some question from the start point with Ms. Aishat, if I'm pronouncing it right, and Ms. Amina, about adding the layers. Could you manage to solve the issue, or is it still not working? Okay, one person solved it, Ms. Aishat. What about Ms. Amina? Is there anybody who has anybody here who has problem with adding layers before moving to the next parts? Okay, great. I see that pretty much everybody has solved it. Later on, again, we can kind of come back, just make sure that the file type is correct. Most of the times, if not all the time, if the file part, the type of the file is not correct, then you might not see the map or get a specific errors. What was the next question going from up? We answered about the colors, and then so about the CRS, do we still have the question, or is it resolved? We had one question to show the CRS again.
Yeah, I think Ismail can show once again.
Yeah, okay. So to add CRS, let me again remove the raster files that has the CRS added, and repeat the process again. Yeah. So to add that layer, you as you know, you go to this raster and you find
Ismail,
the file with. Yeah.
Ismail, sorry, you remove the Google satellite as well, because it will take a lot of data. It will become slow.
All right. So you go to the add layer raster and select a file with no CRS in it. You make sure that file type is TIFF file. Okay. So now that raster file with no CRS has been added, to make sure you can go to properties and see the information with when the file has no CRS, it won't show any information on this. It will be like unnamed like this. So what we want to do is we want to assign CRS to this. The easiest way to assign a CRS to the layer is you can go to that layer, right click, and you go to this layer CRS. In the layer CRS, you have multiple. I have multiple options, which because I have recently been using this coordinate system, but in your case it may not be there, so you have to go to this set layer CRS. In the set layer CRS, the reference system that we are looking is we want to add to this map is WGS 84 EPSG 4326. So since this area is the recently used coordinate reference systems, it may not appear in your map. What you can do is you can go to this geographic coordinate system and you can expand that menu. From that, you go below and try to find WGS 84 with only WGS 84 with nothing nothing is associated with that name. I will show you other like reference system with WGS 84. Yeah. So see, we have many WGS 84 with different references associated with that, but we want to we have to add this on WGS 84 without any other name associated with that. And when you add this reference system, you just have to make sure that the correct EPSG 4326 is along with this reference system. So if it's okay, you can just go and click OK. Now,
so what's the difference between this and the other ones that still don't have any name? Why is this the correct one for us?
So
maybe,
EPSGs are different. If you look at the EPSGs, these are different. And that's why the referencing system is different.
To make sure that that CRS has been like assigned as we did just now, you just go to that layer and go to properties on the information. Now in the CRS part, you will see that the correct reference system has been added to the layer. I hope it's clear.
Actually, one more question to explain a little bit more about properties. So maybe this is a good place to do that.
Yeah. So in properties, what you have options to make the symbology. In this case, symbology means like in CorelDRAW or Paint, you want to change the appearance of the file. You have many options in this. In this case, like atoll boundary, it has the fill color is orange. Like if you want to change the fill color, you can go to this and just change the appearances. So so that's one use of properties, and you have multiple like options here. Whether you want to open the attribute table, you want to find the basic information of the layer, you want to add labels to the layer. You have these multiple options here in the property of any layer.
We will be discussing all these things, vector properties and raster properties, in the next session in a bit detail.
Okay, perfect. And we have one more question about explanation of the integrating Google link into the file.
Integrating which link?
The Google link and Google Map.
Oh, okay. So to add those links, what you have, you must have those URL links, which I believe now already has been shared with in the chat box. So to add a new connection or new open source map to that, you go to this XYZ tiles. You will see on the left side of the window. And click on XYZ tiles, make a right click, and in there you have to make a new connection. You go to the new connection, you name any map that you want to add. Let's say, again, we can try Google Maps. And after naming the file, you can go. What you have to do is you have to copy paste this that URL. Sorry.
This is a review of the document that we're going to share with you in some time soon.
Okay, where is that? Here. So you can paste that link here. Click OK. Now we have like two maps. Previously we had Google Satellite, and now I just add Google Maps to this. And when you want to like add this as a layer, you just double click on it. On the layer zone, it will appear. Now we have the Google Maps on the map view.
And this is only going to work when we have access to the internet, or is there an option of like having offline kind of?
No, we should have the internet connection with us. I hope it's clear now. Is anyone else having difficulties with any of this function?
Yeah, let's open the floor with any of the topics that were mentioned.
Actually, one person was having difficulty seeing the layers that they were adding. So
Yeah.
if possible, Ismail, could you show the check function in the layer box that you can hide and show the layers as well? Because sometimes when you upload layers, they're automatically hidden.
Yeah, so on this panel area, you see all the layers that has already been like imported or added to the map. In case if you want to like if you have it like this, now that Google Maps since we uncheck it here on the panel layer, it's gone. If we want to API it, we can just go and select it again. Just in case, let's say we want to see a toll boundary, and it's not like in appear on the map view. What you can do is you can just go to the layer and right click on it and zoom to layer, and that layer will automatically like go to the center of the screen, and that it will appear. I think some people has difficulties to copy the links too. So maybe is it because we are sending it through the chat, or?
Yeah, so it's a good question.
I think yes, the link is not working when it is copied from the Zoom.
Yeah. Okay.
Okay, let's Opera, can you put it on a Word file and then share the Word file in the chat so people can download it? Maybe that's all the issue.
Yeah, sure.
Thank you. So while we are resolving this part, any other questions? As Prangya mentioned in the third session, we're going to go over some of the more detailed, basically functions of the tool, and you can use the work hands-on to practice some of these aspects and then see what might be the other potential data.
So, Leila, if no one has any further questions, I think I can pass the floor to the next session.
Sure, let's give it 1 more minute, 2 more minutes. Anybody has any questions remaining?
Yeah.
And we are right now preparing to put the data in a file and share it with everyone to make it easier for access. Yes, so one person mentioned about the guidebook. As I mentioned, we are going through, we have prepared the document. Right now, we are going through the guidebook to make sure all of the information are accurate and all of the links are working properly. So in the next few days, we're going to try to share the guidebook before the next capacity building for sure, to give you enough time to practice a little bit on your own as well. Next to the YouTube video of this session, just so that you can kind of look at the function. And of course, during this period of time from now to the next workshop, we would actually encourage you, if at any point you know, you are practicing with the tools and you have some issues or questions, feel free to email us and we try to help you with solving the issues while you're working on basically the functions of QGIS. Okay, so allow me to see if I can share the link with everybody. Opera, can you share the link to the Google Drive that had the data with everybody, not the other link? I'm going to put the Word documents that has the information in that folder so that everybody can get access to the basically links through a Word file. I think that's going to be the easiest way of getting access to the documents. In the meantime, we can take again around 10 minutes for a break. So right now the time is 11:20, I think, if I'm not mistaken. So we can basically resume the session at 11:35 Malay time. And in the meantime, I'm just going to put the data files in the Google. So see you in about 10 minutes. Thank you everyone for participation so far. Okay, the file is uploaded in the Gmail file next to the. So Opera, you have to share the Gmail one, not the box one. Let me just. So, Kang, if you are still in the session, we have a question from Tess.
Yes. Getting an error message on the top after some time that Google links have timed out. Is that fine? Should not timeout. Maybe problem with some connection. So when it is telling you that the links have timed out, does the image disappearing or it's still there?
The image is still there, but I'm just getting a yellow colored error message on the top of the project.
Yeah, let me check. Sometimes that can be related to 2-3 options can be there. Sometimes it can be related to some kind of bug. What is the version you are using?
Uh, 3.28.7.
Okay, that sometimes it's related to some bug, or
Okay.
sometimes it might be related to the link where they have not updated the link, but it doesn't have any effect. Can you zoom in, zoom out, and see different regions into it?
Yeah, I can.
So there is no effect. I think it's fine.
Okay.
Okay. Let's give it 1 or 2 more minutes for everybody to come back. For those who have already joined us, I shared a link to a Google Drive, which has the data that we've been using so far, plus the link to these Google links and the other links that were shared previously in the chat. So you can file the Word document and get access to those information through the Word document instead of using the Zoom. So hopefully that's going to make it easier for everybody. Let's see how many people are back. If you can raise your hand or some reactions so far to tell me that, okay, good. I see few people. Six people. We'll wait 1 more minute and then start with the third session. So in the third session, we are going to continue with introduction to QGIS, looking at a little bit more hands-on advanced information on working with the data. Prangya is going to be the person in charge of this session. As always, please, during the session, if any question comes across, ask in the chat box, and we're going to try to answer as we go ahead. So an evaluation form is already shared. I'm going to share it at the end of the event as well, but it would be helpful if you can answer just to kind of help us see how we're doing and what we can improve. And there is one specific question asking whether you would be interested in the follow-up seminars and workshops that we are going to have as a part of this capacity building for Maldives. And the next capacity building planning is for an in-person workshop in Male. So if you are interested in participating in that, please do fill out the form and answer yes for that part. Okay, Prangya, would you like to take the floor? You are muted.
Oh, sorry. Thank you very much, Laila. So again, we go back to QGIS and do a little more detailed work. Let me share my screen. Is it visible to everybody?
Yes. Okay.
So in this session, like Ismail has already explained the basic functionalities of the of QGIS software, the interface, the menu bar, the toolbars, the browser panel, how to add external images here, the layer panel here, and database data source manager he has used. And I would also like to focus into some of the Zoom tools available in the toolbar. You can also always play around it with the tools, and it will be much easier for you to understand if you just keep on clicking all the tools and get the understand. And this is very user friendly, like Microsoft, any Microsoft software, you just hover around the tools and place the mouse over there, and then you see what the tool is for. So very simple. So is it working? No, it's okay. Is it visible?
What is visible?
My screen is visible?
Yes, it's visible.
Okay. So I will go to a bit detail into vector. First, vector data, its properties, and then I'll go to raster. Let's go to the atoll boundary which Ismail shared earlier. So now in the screen, only this atoll boundary is visible. You can go to this tool, which shows that pan map to selection. And this one for zooming, this one for zoom out, and this one for zoom full. Like if you have a zoomed in version of your map in the map view, then you can just click this one to get the full view of the map, or you can go to zoom layers because we have different layers added here. So to have a full view of the map. So I'll go to the properties first. If you right click on the atoll boundary, if I'm sure that everybody has access to the session 3 data sets. So I am using the session 3 data sets for this session. We have data on atoll boundary. So I have right clicked on the data and went down to the properties, and I'll explain some of its properties here.
Prangya, can you tell us what's the name of the file that you used to?
So this is atoll boundary 2016.shp, the one that Ismail showed how to add. So I'll add again if for your convenience. So I'll removing this, and then I'm going to this data source manager. You can do it from here. You can do it from here. There are several options. Add vector layer, or you can do it from layer, add vector layer. So when you go there, make sure this vector is selected, and under source vector datasets, you go to the browser and go to your folder of session 3, and you can see that there are several files named with the same name but different extensions. So for vector files, when we use a shapefile, each shapefile is associated with this many other auxiliary file. So if any one of these auxiliary files are missing, then you cannot see the vector file in your GIS interface. So you have to make sure that you have all these auxiliary files along with your data. But we are only going to add this .shp. So there are 2 .shps. But if you go to the type, if you have to see that it is SHP file, and then you have to select that one. So you select the file, you open it here, and the file is is shown here, and then you just click add, and then close this window. So somebody was asking about color. So each time you ask a new layer, so it takes a different color. So I'll tell you how to change the colors and make a thematic map as well. So we have added the atoll boundary once again. And when we have added that boundary, it is a vector data.shp extension. We go to the file, select the file in the layer panel, right click on the file, go to the properties. So in the properties, if you see, there are several menus here on the left-hand side. All these menus, all these tools describe the property of that particular vector file, from information, source, symbology, label, mask, 3D view. You can do numerous operations with this tools. I would encourage everybody to go play with this rules or tool so that you understand what they say. So the first one is information. Information is basically giving information about the file. So first one is general. It gives names, where it is stored, and then what are the auxiliary files, what are the size, when it was created, and then the information from provider. It is ESRI shapefile, it is a polygon data, and it has this extension. If you remember, I was talking about the extent of data in the first session. Then it shows the coordinate reference system, which you have already, probably you have understood from Ismail's section. It shows the, the name of the projection system. Like, here, for example, it shows two projection system. One is geographical, that I explained, and another is UTM that also I explained in my first session. So this is a projected file, not the geographic coordinate system, but the projected coordinate system it has. The units, if you see that it shows in meters, not in degree, minute, second, because it has been converted from a spherical project coordinate system to a planar coordinate system. The method is universal transverse marketers, and accuracy world geodetic system, that means WGS 84. EPSG is different because it is converted to UTM zone. And then you see other few information about the data, CRS, extent, all these things. Fields, what are the fields available with the data? I'll come to it later on. So these are the information available here with the data. Then we go to the symbology and see what is the source of the data, similar things, some CRS and then geometry and then, the name, these are showed here. Now, symbology is very important and very useful tool for us. To change the symbols, to make a thematic map, we have to go to the symbology tab. So when you go to symbology, in the right side panel, at the top bar, if you click the drop-down menu, you will have several menus under it, like no symbol. If you don't want to give it any symbol, you have to choose no symbol. If you want to give a single symbol for the entire, all the atoll boundaries, you have to choose single symbol. If you want to give different colors for different atolls, you have to choose categorize. When it is graduated, it will create a, class and give a graduated symbol. For example, graduated, it means like, different shades of the same color. And then if you go to rule based, you have to design some of the rule. Based on that, it will design its symbology. So all the options are there. So let's go to no symbol. If you go to no symbol and then apply, so it will vanish, like it doesn't have any symbol. So it vanishes. So then again, if you go to single symbol and then apply, so it appears, and all the atoll boundaries have just one symbol, just one purple color. We can change the color. When we go here, there are several options. It shows fill. So if you go to fill and simple fill, you can choose other options as well. Like, symbol, layer, types, simple fill. If you click the drop-down menu, you have different types of filling options, like, gradient filling, line pattern filling, arrow filling, some other filling options are also available. You can try it out by your own. So I am giving it a simple fill. And how to change the color? So you go to the next bar and click on the bar, and then you have a color palette open in front of you and choose any color you want. And fill style, solid. That means it will fill the entire polygons into a same color. But if we use kind of, horizontal and then apply, it will show some, this kind of color. This is filling, but with the horizontal layer, not with the colors. So there are different types of texture and different types of filling options available here. So you can try it out by your own. Stroke color is black, that means the boundary. And then stroke width, you can change this width. If you increase it, it will increase the boundary. You can see it here, width of the boundary. If you decrease it, it will decrease. If you can see it here. If you increase, so apply, it will be changed here. If you decrease and then apply, it will be changed here. So that is how the symbology works. Then stroke style is also there, where you can choose a dashed line or dotted line or a single solid line. So all this can be changed from a single symbol property. If we go to categorized, let's go to categorize. When you go to categorize, some other options opens. First one is value. So it will ask you about which is the category you want to be, your symbology be based on. So if you click on the drop down menu, it will give you some of the values. These values are the value, these names are the names of the attribute table. So for example, if I open the attribute table, right click, go to attribute table, open attribute table. So you see, when we have an attribute tables means the non-spatial data associated with this spatial layer. So we have several fields: admin at all, node, northing, easting, shape length, name, then code, the number, and then area, and different other name. So we have all these fields created here in different columns. So when you want to categorize your symbology based on some categories, it will show you the categories of your attribute field. So now you choose, for example, I choose to be based on the name of the atolls. I want each atolls to be colored in different way based on its name. So I added name, and then I can change the symbol. I need to classify. Click classify here. When I classify, it will classify the data according to the name of the atolls. You can see that here, all the atoll names are listed here. And then we can change the symbol as well, like, different colors. We can change different colors, like any color. Color ramp, we can change the color ramp as well. We can choose a color ramp, so it will get changed. When we choose a different color ramp, this color changes. So there are several color ramps already here installed, and you can create your own color ramp as well if you want. Edit your color ramp and save the created color ramp as well. So it is better to use the what is already available, because there is a lot of color ramps are already available. Let's use one of them. I'm using this one, and all the atolls are given different colors, and I don't want this dotted thing in my symbology. So I go to configure symbol. From this drop down menu, I go to configure symbol, and then I go to simple fill, and I want solid. So let's just make it solid. Then it has become solid, no dots inside. And we click apply, and it is colored likewise. So now if I have a legend, if I have a kind of index here written that these colors means this atoll, then I understand from the map and the colors what are the name of the atolls. That is the purpose of symbology. And then again, next tab is labels. So for level also, we have several options here under this drop down menu. First one is no label. If you click no label, there will be no label. If you use single label, then it will give you some options. Again, the value, which label you want for your database. For example, I want to label the atoll names. I want to see the atoll names in the map view. So I put name here. You can put other thing as well. Whatever information you have, you can put it here. You can choose. And then I have chosen name. And then you have several options for formatting this text, and then for all the formatting and all the designing part of the label. So let's see how label works first, and then we'll go to the designing part. I click apply, and now I can see the labels associated with each of the polygons. So labels are associated with each of the polygons. For each atoll, see, it is showing the label here. Now again going to label. I can change the text. If I go to the text, then I can change the font, style, size, color. I want a red label or a blue label or maybe yellow. So I can change it, change the color, and then apply. The color changes. Yeah. And then we go to formatting. So if you increase the spacing, so it will increase the spacing between the letters. You can see it is expanding. The levels are expanding. So, yeah. And then reducing will reduce, no space. Yeah, this is the normal one. And everything sample will be shown here. Whatever changes you make, you can see the sample before applying it to your map. Yeah. So text orientation, of course, it is horizontal. We can make vertical. So it will be vertical. We can make rotation based. You can take the shapes sometime. You can wrap the characters as well. Automatic wrapping, like if you want the symbols to be in 2 lines, and then you can wrap it like normal Microsoft Word wrapping. So we often use this mask as well when we have very dark color map and we have this label on the top of it. So we can enable the mask and we can enhance the size. So if you enhance the size, you see, yeah, there will be a mask of gray color will appear here. Yeah, so we can use that as well. We can change the opacity of the label. Somehow it is not taking, I don't know why. Yeah. So you have to enable draw text buffer as well to use the mask. So now you can see that the labels are very prominent, even if the if it is on the top of some color. So we use this kind of halo or mask around the labels. Again, we go to properties and see other options. Mask we have already done. Fields. Field is very important because field shows you the attribute data fields which are there in your attribute table. You can edit your fields here. For example, here we have atoll boundary. We have names only. But if we want to add any information, for example, we want to add population per atoll. So we can do it from here, and we can do it from other place by opening the attribute table as well. So if we want to edit or add or delete any field here, so we click on this pencil here. It shows that it's toggle editing mode. It will enable the editing mode. Then there will be 2 other buttons which will be activated. One is new field, and the second one is delete field. So if we want to add any new field, we click on the new field, and then this pop-up will come up, and then you add a name. For example, we want to add population for each atoll. You can leave the comment row vacant, empty. If you don't, it's not mandatory, but if you have given your name in some codes or something, then you can put the explanation in the comment bar. then you choose the type of the data. For example, if you click the drop-down menu, there are several types of data. So for population, it is integer, of course, and we use 64-bit. So we choose 64-bit integer, and then we provide the length. So how many, for integers, how many numbers can be stored per cell is the length of the cell. So we put it 10, or we can make it like 20, so that we don't miss any number when we enter the database. And then we click OK. So you see it is there. So population is there. It is added. And if we want to check it, if this is added in the attribute table as well or not, we can go to atoll boundary, right click on it, go to open attribute table. And if we see it, there is a new column with population has been added to it. Sorry. New column, empty column, because we don't have any data in it. So empty column has already been added. So you can also add a new column from here as well. This is the attribute table.
Sorry, where
Yes.
is, I don't see the one that you just. For
Here?
me, the mouse is like fixed and I don't see any move. I don't know if the others can.
Is it?
Prangya, the attribute table was not visible to us.
Okay, let's open it now. Can you see the main window, map view?
You can see the main window.
Okay, let's open it once again. So right click, go to open attribute table, and now is it visible now?
No.
Not
No?
yet.
Are you sharing the desktop or you're sharing the?
Oh, okay. I think I need to share everything, right?
Yes, I think so.
Okay, let me share once again.
And while we're doing this, somebody asked to repeat the part about mask.
How do I share everything? Share screen. Can you see now?
Yeah, we can see it now.
Yeah. So this is the attribute table. I open by clicking, right clicking on the atoll boundary, go to open attribute table, and attribute table will be here. So the new window, new population column has been added here, which I added from the symbol, is from the properties and then fields. So we can do the same thing here as well. So when we go there at the corner, there is same pencil here, toggle editing mode. You click on it, you are able to edit now. And then again, the same buttons here, same options. So go to new field and add maybe temperature as a field. And then it should be decimal number, it's not integer, decimal number. And then it will give you length and precision. 10 is 10 and 3 is, I think it's fine. Precision is the number which will show after the decimal. So 3 places after decimal will be shown if precision is 3. If you increase it to 5, so 5 places after decimal will be shown in the number. So okay. And then we have a new column here. You can delete any column anytime. So you just go to delete field and you will get, it will give you the option to delete the fields. Any field you want, you can delete, you select them and okay, and it will be deleted from your table. It's gone. So that is adding data, adding the field. And then when again we go to the properties, and then we see joins. So for joins, what we do in vector analysis, we have many data. For example, we have a atoll boundary, We have one data on island boundary. We have data on land use characteristics. So we want to integrate all this data into a single layer. For example, data means the attribute data. We want to integrate all the attribute data into a single layer. For example, my land use data does not have information on the name of the islands. For example, this is my if you can open this agricultural area Maldives for join. This data, this layer, this layer, we open the attribute table, and then this layer, you can see the attribute table in this layer. So I want to include the island name as well in this database. It doesn't have. And also I want to include all the data that the island boundary has. So what we have here is the class name, we have area, we have its atoll name, and we have one very important field called F code, which is the code. I think it is, my colleagues here from Land Survey Authority can identify. This is the code from, from the administrative boundaries. They have used code for each and every atolls. So also we have island boundary here. If you add it, so if you open the island boundary, it also has this F code. This F code. So I want all this information to go to my agricultural area, because I want to know how many agricultural area, how big, what are the agricultural area available for each and every island. So to know that, I have to right click, go to properties, and then go to joins. Join will add the attribute tables from 2 different vector layers, which has at least one column common. Here in this case, it is the F code. So if you want to join two attribute table from different vector layers, you have to have one common column. If you want to use the atoll name or any other name as a common column, it is always safe to use any code. But if you want to use the name, you have to make sure in both the layer, the names are spelled properly, because this is case sensitive and spelling sensitive operation. So when I add here, that means I have selected this agricultural area Maldives as my source vector layer, where I want to add the island information. So I clicked on the agricultural area and then went to join. If you want the other way around, if you want to join the table of agricultural area to the island layer, you have to select island layer, and then you have to select island layer and then right click and then join. So when I click join, that will ask me which layer I want to join. So I want to join this island boundary. And then join field, F code. This is a common field between these two layers. And targeted field, again F code. So these is the common field. It has the same property of the basic DBMS, which uses a common field to associate different databases from different sources. So that's it. And then I press OK. and then press OK. And then we check if it is already added or not. Let's check it. So yeah, so you can see now all the information of the island layer has been added here. Like it only had until this F code column, but it has also added other, the name of the island. You see the name of the island it has added here, all the way down to the all the rows. So this is how join works. But after you do the join, you need to save this data. Otherwise, when you you remove this data from this interface, it will lose the join. So if you want to make this join permanent, you have to right click on the layer where you have done the join, and then go to export, and then go to save feature as. You have to save the feature, and then you navigate. ESRI shapefile, of course, we are working with vector data. We have to give our file name and navigate to the working folder. And we can give it like, agricultural Maldives. Give a suitable name, whatever you want. Joint island data. And make sure this is the file type it's showing, and then save. And then, okay. Yeah. So in the new data has been added here. So if you open this one again, attribute table, all the data is here. All the data is here. But for example, I was telling, if you remove this data before saving it, let's see what happens. I'm removing the other one. I'm not saving it. And then if I want to add this one once again, this one. Okay, when you want, no, that's okay. I think there, add layer, add vector layer, yep. Now add the previous one, open, add, close. So this one, this one is the earlier one. And when we open, you see, I did not save it. So there is no extended, table for this one. So make sure you save it. So next one, what I'll show is how you create a new vector data. So to create a new vector data, you go to layer, create layer. So when you go to create layer, it shows you several options, like you have GeoPackage, shapefile, all these options, but we will only create shapefile layer. So we click on the new shapefile layer. I'm stopping for a bit and checking the questions. Should I check the questions now or later on?
I think it's a good idea if we check the questions and see so far what are the questions. First, actually, there was a good tip from Mr. Imad, Mohammad Imad from Ministry of Housing. So F6 is the shortcut for viewing attribute tables. For those people that get more comfortable with using shortcuts.
Yeah.
I had one question about adding information to the field. For example, if you want to add population on every atoll.
I'll show it later on.
And then can we display the joint data on the atolls?
Yes, of course. We can display it as a label if you want. You can display it. So this one is the one with join table. Yes, QGIS has several shortcuts. I'm not showing all the shortcuts because for the beginners, it's not very comfortable. But of course, you can go to the website and see the guidelines so that you can also learn the shortcuts later on. So for example, we want to show the name of the islands here with the agricultural data. So again, we go to properties. We go to labels and we go to single labels, like I said before. And you check the value. Last time we chose atoll name, but this time you have to choose island name, I think. Okay. Let's check. Let's check the attribute table first. Fields. So under fields, I think this is the one. First one was that all name, and then go to level and we check the, we choose the first one, and then let's see. Yep. No, this is not the one. Maybe this one. Yeah. So this is the one. This is the island name. So if you go to this agricultural area, so you see the island names for each agricultural land parcels.
Okay, great. Any other questions? So for the island population, Pragya is going to go over that.
Yeah.
Anything else that anybody wants to ask before we move forward? Okay, I don't see any questions. I think we can go to the next one.
Okay, so now we'll go to see how we can create a new vector file. And so we go to layer and then go to create layer and go to new shapefile layer. So when you click on the new shapefile layer, it will, this new dialog box opens, which will ask you to choose the file name. So you click on the dotted lines here, and if, for example, you want to create a shapefile about maybe protected area. I prefer to name always with underscore. Sometimes some softwares, they allow space in between the words in names, but sometimes some software doesn't allow. In that case, if you want to use same data for a different software, it becomes a hassle to changing the name. So I always prefer to use, and I also suggest to use either an underscore or a non-space, like you don't put any space between the words, so it's easy. So we save this as a protected area, and then you keep it as it is, and then geometry type, you have to choose a geometry type. Now the protected area is an area, of course, so we want to make it, we can make it either a polygon, or we can make it either a line string, and then you convert the line string into a polygon. So we can make it, we can make the area as polygon. Let's go for a simple one first. And here also, if you want to add the fields, which will appear in the attribute table, if you know the fields, then you can add. For example, I know the name, for example, name of the protected area. It is a text string, of course, length is 80, it's fine. And then you click on add to the field list, so it will be added. So when you open the attribute table, these fields will be already there. Again, you can add another field, and as many as as many field as you want, you can add, for example, area. So it will be a decimal, and again, length and precision, you can decide, add to the list. So, and then click OK. So your protected area is here. I'll remove some of the files.
When we are creating these new values, can we at the same time edit the names if you have problem with the name of the column, just to make things?
Here?
Yes, when you're looking at the attribute table.
So I think you can edit here as well, I think, name. If you
Okay.
want to change area, maybe square kilometer. I want area and square kilometer. So name is edited here. And it will be visible in the table as well. So a new shapefile is, properties. New shapefile is created, and it has the same, did I mention this CRS? I think I did not. Let's do it once again. Layer, and then create layer, new shapefile layer. So it will ask you for the CRS. I'm just showing you because I forgot to mention this. Ask you for this CRS. So we generally use this one, WGC84, EPSG 4326. So if it is here, then you don't need to change. If it is not here, you click this earth here, select CRS, and it will lead to the same window that Ismail showed that time. And you go to predefined reference systems, go to the top, go to geographic coordinate system, and then you find WGS84. The same way. So when we have this data with us, now we want to add it or add some, new areas, protected area. For example, we have a Google map here. We want to digitize it on the top of the Google map. It might take some time. Let's remove connection and once again do it. New connection and Google Map. Then I copy it from the source and then URL. Okay, should we add it here? Yes. Let's see if I can add it or not. Might be taking some time because of the connection. Let's try another one. Oops. Yeah, so it's here. So let's zoom into Maldives. For example, this one. And we see the, for example, this is a protected area and we want to digitize a polygon around it. So when we have this one, we need to add the digitization toolbar. So Ismail showed it in the previous session. Again, I'm showing it. You go to view, go to toolbar and go to digitization toolbar. When you check this box, a new toolbar will be added, this one. This one will be added here where you can see the pencils. So again, to start the work, to start adding features into your new vector layer, you have to toggle editing. When you toggle editing, it will show here as well that your layer is editable now. So when we do that, then you go to this icon, this tool, which shows add polygon feature. Now you click here and you start clicking around this polygon. And when you finish digitizing this one, you right click. When you right click, when you cover entire area, you right click. When you right click, this window will pop up. You put an ID. For example, you are using a number, maybe 1, and maybe name PA Gafu Alifu, and area, leave it, and we can say okay. And when you open the attribute table, you will have one entry in your attribute table. So that's how you digitize and add data in your newly created data layer. Same thing, you can do it. For example, if you are so if you go here, I think we can go to symbology, simple fill, apply. Oops. Yeah, it's here. So it's a kind of problem of the connection. So with the satellite data, it cannot handle that much of data into it. So this is the newly created area file, polygon file, and we can keep adding this polygon. Oh, okay, I know why it is happening. Oh, yeah. So because GIS is all about overlaying things, so you need to understand which layer goes to the top. If you understand that, then put the layer on the top and then the other layer below it. So if you want to add more data into it, so you navigate, you pan, this is a pan button here, and then you navigate somewhere here. And
I have a question about this zooming in. If we don't know the exact location, like visually, but we know the latitude, longitude, or other information of the location, is there a way that we can zoom in using those information, or we have to know where it's located when we are using this type of online resources?
You mean the latitude, longitude of a...
Like a position in the island, for example, or boundaries of the island. Like, is there a way that, because you might, like, I personally, of course, like colleagues from Maldives know the locations better, but if somebody asked me to find like some specific island to do this kind of stuff on, I might not know exactly where is the location in the overall. So do I need to find it using Google Map or something and then visually kind of find it in the app, or is there a way to use the name, or I don't know, the basically location in terms of
No, there are two options. For example, if you know the exact location, that should be a point feature, because for area you don't have a specific location, right? If you are not using a Google Map at all, then you cannot draw an area because you don't know the area, right? You just know the point. So if you have a point data and you know the latitude, longitude, you can actually populate that in an Excel file, and then you can actually import this on a GIS environment and actually convert those Excel latitude, longitude data into a XY into the GIS environment. That can be done. But for area, you need to have a kind of background image or at least some map or something for reference to actually draw the area.
I see, thank you. And there is one question from Ms. Fatima Shazli. Can you be more specific of which parts? Like, is it about how to, choose the area, or about how to match it, or everything together? She asked, can you explain again, please? But I'm not sure.
This one.
Yeah, that's why I'm asking if she can elaborate which part we're...
Yeah, if you're asking this one, I can explain again.
Oh.
How she identifies that? Okay. It's just I know the location, not location actually. I know where Maldives is. I think everybody knows where Maldives is. So again, if you have a boundary, so you can put the boundary on the top, so you know where the atoll boundaries are. So I had atoll boundary, it was down here. So I just took it to the top so that I know where the atoll boundaries are. And then, because if it is if it is filled symbol, we cannot see what is there underneath. So let's change the symbology and go to simple line. If we go to simple line, it will have just the boundary of the atoll. So because it is black, it is not showing here. Let's change the color as well. Make it yellow, probably a bright yellow. Okay. Okay, now see. Now you have the boundary, okay, over the imagery. And you can zoom into any of the area. Like, you know the map of your country, right? I mean, you can zoom into any of the area and just scroll. What I did, I just scrolled over the entire country and I found that this island, this area, it has an island. So I create another polygon here. Like I draw a polygon here. When you finish drawing, you have to right click. So this window will pop up. Again, the number 2, and the name may be some protected area, GA2, something like that, whatever name you want to give. So that's how it's created. That's how you can create it. Polygon layers. Now, if we have some point features, we can also create a point database. And same thing, you go to layer and then create layer, new shapefile layer, and then you give one file name, maybe mobile towers, for example. And make sure it is SHP. Save. When you save, it will ask about geometry. Make sure it is WGS84 and this EPSG 4326. And for field, you can give the name of service provider. Make it service provider. And then it is text. It's fine. And then add to the field list. It's done. And what else is remaining? Geometry type. Okay, is a point layer, so I choose point. So okay, so new mobile tower data, point data is created. For example, if you have mobile data somewhere here in Mali, for example, it is Mali. So we see that somewhere here, then we have to save this data, the protected area that we were doing. So here is a floppy sign with a pencil, that is save button, like the Windows, all Windows system. And then we make it non-editable again. So toggle the editable editing, and then we select and make it editable. When we make it editable, see now the change, it has changed. Earlier, when we were doing the protected area, here there was a polygon like area icon. Now it has a point icon. So we know that we are going to add the point features. They also know. So we take this, choose this one, and if we know where the mobile tower is, then we just put it here, and then it will again ask you for the data. For example, ID is 1, some service provider is, I don't know if I'm writing the spelling correctly or not. This is the one I used when I went to Maldives. So I press OK. So again, if you want to change the visibility, you go to properties, you go to symbology, you to simple markers, and you have many options to choose the color or something, I always choose a bright color so that it is visible at the, over the black, darker background. So it is there. You can change the size as well. You can change it to 10 probably. Okay. So now it's visible. So that's how we create new vector data. So we learn new vector data, creating vector data, and then digitizing vector data. Now, when we are creating, for example, land use data, I don't want to teach land use data now, but just for your information, when we create land use data, then though the land use classes are polygons, like it represent an area, for example, urban area represent an area, protected area, an area, agricultural area, we don't generally create a polygon file, because, for example, when we let's make it, save it, and then, for example, let's go to somewhere else.
Just as a note, time-wise, we are getting now at the borderline of out of the workshop time.
Am I? Okay.
Yes, it's already 12:30 in Maldives.
Okay. So what do we do?
So I mean, we can continue for those people who are able to keep up a little bit more with us, if it's okay, just to make sure we can cover up the necessary parts as much as possible. And those that want to leave, please do fill out the evaluation form, and we'll share the link to the YouTube as well as the guideline with you soon. And we really appreciate your participation so far and staying with us through the process. But you can go ahead. I think we can add, if it's okay.
Yeah, I'll just add two, three more points into the vector, and then I'll just rush to raster. So I was going slow because I was not sure everybody will follow it, I mean, properly or not. Anyway, so this is the area where we can see, these are the urban areas. These are the agricultural areas. You can see from the pattern, right? So these are areas which are like, closely spaced, one just after another. There is no clear boundary between them. So if we add, for example, if we add a polygon here, for example, a polygon here, and tree name, urban, okay. And then when we want to add another polygon, for a different land cover class, so there will be a conflict over one boundary, which will these two polygon will share. So GIS, they don't understand this sharing part. So there will be for the same one boundary, two lines will be there. So there will be conflict for the software to understand the relationship between these two polygons, which is called the topology. So they cannot, then there will be like, vacant space in between. You see, it's not added. So it's not taking, common boundary. It doesn't take. In that case, what we do, we actually create a line file and draw everything in line. And then we convert this line into polygon. I think we will be teaching all these things, sharing all these things in our, in-person capacity building in July. So I'll stop for the vector one here. If I don't know, Laila, do we need to take a break or not? If we don't need to take, I can just continue.
I leave it to the colleagues from Maldives, because I mean, it's their time that we are taking like extra time. Would you prefer to take maybe 5 minutes of break, or would you prefer to continue? Now this is the time to kind of use the chat box and share your opinion. or unmute yourself and share your opinion. Okay, we have two opinions, opposite directions. So I think we can take the middle ground. Let's take like 5 minutes. So it's 1:03 right now, my time. Now it's like so 12:33 Mali time. Let's meet up at 12:10. Is it correct? No, 12:40. 12:40. And then we continue with the raster data and the last part of the setting. Thank you everyone for your collaboration and cooperation. And yeah, we'll continue in like just a few minutes. Pragya, you might wanna stop the share if you wanna check your other stuff. Just. Okay, since we are taking that 5 minutes break, within that 5 minutes, if everybody has any question that you want to ask so far, I think this would be a good opportunity to ask your question from the first part that Pragya has shared with us. I add one or two things since I think my concluding remarks are going to be dropped. I would really appreciate it for the next workshops as you managed to participate here today to spread the word because we are hoping to basically have as many people as possible to get to know the data that is available, the projections and the work that is being done, especially from the youth side. If you know students or colleagues from Maldives National University, I think we had actually 1 or 2 participants from the university. But if you know people who might be interested in learning about the data or the project from the younger generation, do introduce them to us. You can use my email and contact me directly, and we'll try to basically include them in the next sessions of our capacity building and workshops that we have in the next few months. Prangya, we have a question from Mohammed Imad. If you can answer that.
I think if anybody from NDMA is still here, they can also answer. What we have done is they have some tabular database. So as part of the project, they whatever data they have, we have imported into GIS, like for disaster loss and damage from 2013 to 2000, the latest one. They had tabular data, so that data we have imported into GIS format, but that is not very much in detail. But yeah, whatever they have, we have it georeference in the GIS interface. Like they have the data on previous occurrence of drought, floods, water shortage, erosion, storms, swells, and they have some estimated amount of compensation given to the people. That part is there with us.
Prangi, I think you can start sharing your basically page and all, so that we start right at 1:10, or 30 minutes before that in Malta.
I can start doing the next one.
I think by the time you share your desktop and all, it's gonna be the time. Sorry, I'm getting confused with the exchange of the time zones and also.
So is it visible?
Yes.
I think 1 more minute, then we can start, right? It's 2:40. Like it's 12:40, right?
Yes, we can start.
Okay, so this part we have done a few work on the vector data. Now we will look at our raster data, how they look and how we are going to work on that. So basically, this is one of the raster data. As I was talking about when I was talking about raster data, that it is formed of pixels. If you could see my screen, these are the pixels, and each pixel has its own value. For example, if we take this tool and then click here, so it will show us that what is the value of that specific pixel. This data is just single band data, so it is showing band 1. There are a lot of other data which are multi-band. I think for that you need to study remote sensing a bit. I'm not going to do details. So there that will show the value for different bands, but this is a single band data, so it is just one value. So this is a precipitation data, precipitation projection data, precipitation data for annual precipitation from 1981 to 2000, and so pixel we have seen. We can expand this layer to see the range of the data. So it shows that the black part has the lower value, the lower range, and then as it gets lighter, the higher value changes. We can change it, and let's look at the properties. So similar tabs we have here as well, as we saw in vector information. It will show you about the similar information along with CRS. Source and information are quite similar. For symbology, it is a little different because it is a raster data. The data is different, so render type is different. So there are several options, and multiband color, of course, for multiband data, paletted unique values. If a raster data has a unique value, for example, if the raster data has 10 pixels and 10 pixels has just unique values, all the raster data has unique values per pixel, but this is a big raster data. If we want to show the unique value for thousands of pixels, it is very difficult. I mean, it cannot handle sometime But if we have a smaller data sets where just like, few pixels are there, then we can render a paletted univalue. Single band gray, that is what we are looking at now. And then single band pseudo color. So we can, in pseudo color, we can give it a color. So let's choose single band pseudo color. So if we say single band pseudo color, it gives you the minimum maximum range. There are different types of interpolation available. The way we look at the data, there will be discrete, linear, and exact. Generally, we use discrete when we want to see the data into different classes. Linear will show you the same thing as it is showing now. Exact, again. And then if we want to see discrete, it will give us the option to classify. So if we want to classify the data into different ranges, for example, we want to see because if we look at the data, the range is from 16842 to 2439. Approximately. So if we want to see the data which are below 2000 and above 2000, then we can have the classes divided here. So here automatically by default, it will divide the classes into several classes, but we can choose how many we want to see. So accordingly, we can either add or subtract the classes. So I want to subtract the classes. I just want to see 2 classes. Let's make it just 2 classes. And first one value, I want to see from up to 2000, and the second one above 2000. So let's apply and then see. We can see that these are the areas where it will show you the legend here. So less than 2000 is pink color and greater than 2000 is green color. So that's how we can make the symbology of a raster. Again, I'm going to the properties, and there are several options for color ramp, as we saw in vector data as well. We can check the transparency of the layer by moving this bar. So if you reduce the transparency, its visibility reduces. If you increase the transparency, its visibility increases. How it is applied? When we have 2-3 layers, one top of another, then we can actually prioritize which layer we want to see in our map. Then we can actually control this visibility. That's how we use it. So symbology is done. And then we will go to some of the operations with the vector data. So first one is, for example, if we have these are the operations I'm talking about, we generally use in our everyday raster analysis. Also, we used it for our work under Maldives projects. And these are the operations we will be using when we go for the next phase of capacity building. So I just wanted to focus on this analysis. There's several options available for raster analysis. I will just pick, I have just picked few and then I'll explain them. So first one is clipping a raster. Clipping means, if you have a bigger raster and you just want to make a subset of that raster into a smaller area, how do you do that? Maybe for example, you don't need that big area. For example, in this raster, this is a raster we have got. But then we have so many spaces here and there. When we process the data, it might take longer if we have a larger file. So we want to clip it to this level, which is much smaller. This is the area where we want to clip it. So for that, I have created a shape file, a polygon shape file with the area I need, just a polygon shape file, like I created in the vector analysis part. So when we have it, then what we do, we go to processing toolbar. So we go to from here processing and then toolbox, like Ismail showed in the previous session. And then you type clip raster. So when you go to clip raster, it will show you several options, but we will use clip raster by mask layer because we already have a layer here, mask layer. It will mask out the actual area we need. So if we double click on this tool, it will it will show this window. So input layer is of course your layer, which is this one, 1981 to 2000, 1981 to 2000. Mask layer, from the drop down list, we choose MLD AOI. This is the mask layer I'm using. Source CRS is the same one. Target CRS is also the same one, WGS 84. And then the rest of the fields, I think you can keep it as it is by default. And then you can either make it a temporary file if you don't want to save it. If you are trying out something, then you make it a temporary file, or if you want to save it, you can just click here and save to file. So I'll go to the section 3 data folder, and then I'll name it as clip. It will take a .tif extension automatically. I'll press save and then run. So when you do run, so a new file has been created with the name of clip. So I have unchecked the others which I don't need. So this is the one with the clipped version. The earlier version was bigger, the new version is smaller. So that's how we can clip a raster. And next operation will be to resample a raster. Resampling means sometimes when we are using different rasters from different sources, sometimes their resolutions might not match. For example, in our analysis, we are using climate data, which has a 5 kilometer by 5 kilometer resolution. Then again, we are using another population data, which has a lower than 1 kilometer resolution. So when we want to integrate these two data to find out population in different climate zones, then we cannot do it unless and until we have the resolution is same. Otherwise, there will be a lot of data loss. In that case, we use resample. Resample will change the resolution of the raster. So if we want to resample, you again go to the processing toolbox and type resample.
Pranga, if somebody tried to merge them without resampling, then what do you mean by the data will be lost? It's going to be one-to-one resampling and then the rest of them are going to be deleted? Is that how it happens?
Yes, it will not be, for example, we have a raster which is 5 kilometer by 5 kilometer. Now we have information only about this big area. But then if we have the population data, which has a much smaller, resolution, when we try to integrate this to, when actually we do multiply, when we want to multiply these two images or do any mathematical operation, the number we get of from the population data will be like wrong. It will not be correct because their resolutions are different. Their multiplications are not one-to-one. So any kind of mathematical operation will not be one-to-one. So that's why when we work with different raster layer from different sources and different resolutions, we always need to bring it to the same level in terms of resolution to get the best result.
Right.
So for resampling, we use a warp tool. We use warp reproject tool. This one. Again, we type it warp and we get warp reproject tool here. And then before resampling, for example, if we look at the properties here of one of the raster layers, so if we go to information, we check it that the pixel size is 0.0416 by 0.0416. Let's, for example, we want to change it to less than this. So 0.041, maybe less than 0.03 or 0.02, then how to do it? Then we click on warp reproject. The input layer is my layer, which is already selected here. Source CRS, Source CRS is this one. Target CRS is again this one. For resampling method, you have several options. If you know, I am not going to a very theoretical, part of all these resampling options. We generally use nearest neighborhood, because nearest neighborhood is the concept is like, it looks into the nearest pixels of a particular pixel, and then it resamples itself. So most of the cases we use nearest neighborhood unless and until you are sure about, know the background of other resampling methods, and you are sure that is going to work for your or for your data, then you can use it. Otherwise, nearest neighborhood is the most safest option. So we go for nearest neighborhood. No data value is fine. We can set it for 0. And then we go to save file. Output data as input data, it's fine. And then we just go to save, reproject, save to a file. Then we type reproject. And again, the file type is TIFF, and we save and we run. When we run, a new file has been created. So let's check the resolution if it is resampled or not. Oops, sorry, I forgot to mention the resolution. Let's do it once again. Reproject, okay. This one, and then this one, then target CRS, nearest neighborhood, no data value maybe 0, output file resolution. So when you go to output file resolution in target georeference util, I put 0.02. Because that one is 0.04, let's make it a lesser one. And then we save to file, then mix reproject version 2, save, and then run. So we have a reproject version 2, and let's check the property. And now you see the resolution is changed here, 0.02. So that's how you resample a file or reproject a file, change the resolution of that particular file. So this one is also done. And then we can do a lot of mathematical operation using rasters. One is called the raster calculator. So like the normal calculator, there is raster calculator as well. When you have data added in your layer panel, when you open a raster calculator, it will be visible in your calculator window. So if you want to do any kind of mathematical operation with your raster data sets, for example, I have two data precipitation data, one from 1981 and one from 1982, yearly precipitation data. So I want to take an average of these two data. How do I do that? It's pretty simple. So I double click on this one and then put add, and again double click. When we have this one, I make a bracket here. It's just like normal mathematical operation, and divided by 2. Divide option and then press 2. And then we give a name of this file. And file name is, for example, addition or average. We save it, and output CRS, make it sure that it is here, and then I press OK. Raster calculated is complete. I have another average file which has calculated the average values of those two rasters. With the raster calculator, you can do many calculation, whatever calculation you want to do. Some of the operators are also there. You can select some of the data. For example, if I want to from these data sets, Single brand way, okay. For example, if I want to see from this database, make a separate file from this database with the precipitation value above 1,500, for example. I can do it from raster calculator. So I choose this one. I double click on this one. And I mention that 1.1500. I want the data above, sorry, maybe 1800, 1800. And then make a bracket and make a, these expressions, I think I have given some of the examples in the guidebook that will be helpful for you. But otherwise, if you want to learn about the expressions, I mean, online guidebook is available. You can go there and learn how to write these expressions. So output layer is maybe class 1800. Here more than 1800. We save it. And this one, and okay. And we can expand, and it's showing like everything more than 1800. It is here. So zero color, for example. This one is 0. Here means there the values are less than 1800, and for the rest of the rasters, the values are more than 1800. So I think I should stop here. One last thing I just want to mention, which is the zonal statistics that I'll just mention. Zonal statistics is important to find out the raster value for a specific zones. So if we want to understand what is the precipitation for each atoll, average precipitation, annual precipitation for each atoll, then we can do zonal statistics. We again type zonal statistics here, and then new window will come. Then input layer would be the precipitation, the zone data atoll boundary, and raster layer will be the one we were using there, this one. And then we have option statistics to calculate. For example, we want count, sum, mean, all. Let's make it, let's keep all these things. And then zonal statistics output file, save to a file. It will create a shape file. Zonal PR, precipitation, save. And then we run. As we run, we have a new zonal PR. So if we open the attribute table, it will show you this count, sum, and mean precipitation for each atoll. So atoll is here, and then you have the precipitation mean and sum of precipitation of the entire atoll, or any other statistics you want to get will be enlisted in the column here. So this is called zonal statistics. I think I should stop here. It's already 30 minutes over, and yeah, over to you, Laila. And if you have any question, either you can ask me now, or you can just send me email regarding the question. I would try to answer.
Yes, I shared the email for myself as well as Prangya and Opera in the email chat. So if you have any questions regarding the QGIS, you can email Pragya directly. And if there are any questions regarding participation in the upcoming workshops, please feel free to directly email me. It's been a pleasure having all of you, and I'm happy to see so many people actually were willing to spend half an hour extra to stay with us for this workshop. And we really hope that you find this material useful. So in the next workshop, we are planning to add on top of basically the basic introduction that we had, to go more deeply into the data and the QGIS use in the case of a specific case of Maldives, to basically discuss more regarding the methodologies of the project that we are working on, and the data use, and more technical aspect related to risk and resilient works that are done so far. So again, if you can, please do fill out the evaluation form and let us know if you're interested in participating in the upcoming workshops. That the next one is going to be hopefully the second week of July. We are planning a 2 days workshop that is going to be very heavily working on different topics related to spatial data, GIS, and of course the project in the Maldives. Again, thank you all. I'm not going to take more of your time. It's past lunchtime, I guess, for many people. So enjoy the rest of your day, and I'll be sharing the link of the YouTube plus the slide and other documents with you very soon. Have a great day, and thank you again. Goodbye.